Hi, Clark. This is the problem that I sent you, and this is how to do it. So, here's the problem. Let me see if I can get this on the same page. Alright, okay. Whoops. Okay, so there's the problem. Yes, and here's how to do it. First I make my north, south, east, west lines for the bearing. There it is. North, south, west, east. And this is the north. This is the west. This is the east. And this is the south, of course. And the plane is going S40 east. Okay, so that means south 40 degrees in the east direction. So I'll make this a green line. So south 40 degrees in the east direction, and it's 2 hours at 150 miles per hour. So I'd say this is about 40 degrees. So I'll type that in here. This right here, this is 40 degrees. And the distance is 150 miles per hour for 2 hours, so that's 300 miles. Next, it then changes direction to S70 west. All right, now first of all, I need to figure out what is S70 west. What does that mean? This is what S70 west means. S down this way, to the west this way, 70 degrees, so that's about a little less than 90, so something like that. That's S70 west. Okay. Here. This is S70 west, meaning this angle measure right here is 70 degrees, and that means that this angle measure back here is only 20 degrees. Okay, now that's not where the plane went. Where the plane went is just parallel to that, so I'll keep it in green. Now the plane is now over here, and it went parallel to that red line, so this is nice and parallel. There we are. So down here, right here, that's the end point after it goes 3 more hours. That's 160 miles per hour. Now 160 miles per hour for 3 hours is 480 miles, so I can label this distance as 480 miles. Alright, now then the question is, after those 3 hours, how far is the plane from its starting point and what is its current bearing? So how far from the starting point, that would be, see, what we want to know is, this is the starting point here, and it is this distance away from the starting point. So I need the length of this blue line, and for the bearing, I need the angle right here. So I need this angle right here. Alright? You could see that I have made a triangle, so let me go label this triangle with some letters, so I could use the law of sines or the law of cosines. I'll call that A, call this B, call this C. So since A is up here, this green thing down here, this is going to be A. And this equals 480 miles. I think I had 480 down there somewhere, but it disappeared. It was like this. 480 miles. Alright, okay. And then the little b is what I don't know. So this b here, this blue line, this is what I want to know. And then this little c here is 300 miles. 300 miles is c. Alright, so now let's see what I've got here. I've got, I don't have an angle because I only know part of this angle, not the other part. But I do have a side. And do I know this angle? Yes, I do know this angle. Because this angle is 40 degrees, and this I turned using a known bearing. So this red line represents the known bearing. It's parallel to this green line, of course. Now, what is this angle right here? Let's see. This angle is 70 degrees. So this angle is 110 degrees. So if this line, red, is parallel to this line, green, then this angle from red to green, which is 110 degrees, should be supplementary to this angle. So 110 degrees, 70 plus 40, 110 degrees minus 180 degrees, that leaves me with 70 degrees. So this must be 70 degrees. Oops, put that in green. 70 degrees. So I have a known angle here of 70 degrees. That's great. All right. Now, there are several different ways to have arrived at this 70 degree angle. I could also have used this line here. If it's 70 degrees from the red line to the center black line, the red line is parallel to this green line, so this angle measure, 70 degrees, should be equal to this angle measure over here, because alternating angles are equal in parallel lines from your geometry class. So if this angle is 70 degrees, then, and this angle is 40 degrees, 40 plus 70 is 110, and 180 minus 110 is 70. So you could have arrived at this angle 70 degrees with that also. Alright, so now I have a side, an angle, and a side. So I'm going to use the law of cosines. So the angle is angle B, so I can solve for this, side B. So B, I'll do this in black. B squared equals, I'll just put in the squareds later. B squared equals A squared plus C squared minus 2AC times cosine B. And now I'll put in the squareds. Squared, squared, squared. Okay. So that's the formula that I'm going to use. So B squared equals, A squared was 480. 480 squared. C squared is 300. So 300 squared minus 2 times 480. I'll make this line longer. Times 300. Cosine, and the angle B here is 70, so cosine 70, and that's going to end up equaling some number, and it ends up being 471 point some junk, so it's about 471 miles. So here, this ends up being 471 miles. Now for the bearing, I need this blue angle, of course, from the north-south axis to the blue line. So this is going to be a south, and then this blue angle, west bearing. So the bearing is going to be south, and then this angle, and then west. So what is this angle? Well, let's see. To find this angle, I'm going to need the angle here. So I'm going to need this I'm going to need this purple angle. I'm going to need this purple angle here. Like angle A, in other words. I'm going to need angle A. Once I get angle A, I'll subtract 40 from that to get this blue angle. So how do I find angle A? I will use my favorite, of course, the law of cosines again. So law of cosine says A squared equals B squared plus C squared minus 2BC cosine A. And now I'll put in the squareds. Squared, squared, squared. Okay. So, I'm going to solve, because I don't know what A is, and that's what I want to know, I'm going to solve this equation for that capital A. I add this 2bc cosine A on both sides. And that's going to make this b squared plus c squared. Right? Okay. And then I'm going to subtract a squared on both sides. 2bc cos A equals b squared plus c squared minus a squared. And I'm going to divide both sides by 2bc so I can have cosine A alone. So cosine A equals b squared plus c squared minus a squared over 2bc. Alright, there's my fraction bar. Okay, so I substitute stuff in here, so end up with A equal to the inverse cosine of some junk, and it ends up being the case that A is about 73 point some degrees. And so the answer is 471 miles, bearing south 73 degrees west. All right. So that is the answer. Let me put a degree symbol here. All right. And let me box the answer. Box the answer. Okay. So that is how it is done. Of course, here I've just left the variables here just to be fast, but you know, I should have put 471 squared in there. I should have put 300 squared in there. I should have put 480 squared in there, and then 480 and 300 in here. And that is all.